Algorithm is a heavy word, right? We can break it down. So algorithm, the definition of algorithm is set of steps. So a simple algorithm, I'll give you an example. Like if I ask you what is the mean value of let's say 2, 7, 10, 15. So to calculate the mean value of this, what you will do, I mean, this is hard coded in your head. So what you'll say that, okay, first calculate the sum, calculate sum of all numbers. Yes, this is what you'll do. So 2 plus 7 plus 10 plus 15. Any fast computational people in the house, can you tell me what is the sum?
34.
Oh my god, I'm jealous all of you. 34. I couldn't do this faster. So so 34 is the sum. Then the second step is, in this algorithm of calculating the mean value, is what? Divide the sum by number of values. So 34 divided by 4, right? So this gives you the mean value. So these two simple steps which you have done is nothing but an algorithm for mean value calculation. Okay. Similarly, when I say linear regression, so it will do one step, then second step, then third step, then fourth step, and then it will produce certain results. So that is linear regression algorithm. Okay, so an algorithm is nothing but a set of steps. So when we say linear regression or decision trees or random forest, the set of steps might be little more, but in the end, all these set of steps are what? If else statements, one after the other. So if something is true, then do this. No, okay, do that. Then once again, if something is true, then do this or do that. So on and so forth. The logic is made, and we will go through the logic for all these algorithms during our courses. What is a data scientist? So a data scientist is a combination of three disciplines: statistics, coding, and domain. So essentially you need to understand these algorithms first. Okay, you also need to understand how do I code them in R, Python, SAS, etc. Any one language. You don't have to know all the languages. If you know only Python, that is fine. If you know only R, that is also fine, but you have to know at least once. Then the domain knowledge is kind of desirable. I mean, if you're working in a company, let's say, who is manufacturing um, mm, let's say let's say you are working for a company who manufactures a medicine. Okay, so if you do not understand the domain of medicine manufacturing, then you won't be able to create good solutions. Okay, if you are working for a company who is into insurance, so if you do not understand the basics of insurance, like if somebody submits a claim, what are the important factors to look for, like what is the claim amount, what was the insurance years, how many years he was insured, was he started the insurance just last month and started to claim this month, so is this a fraudulent claim, so what are the factors which will trigger this suspicion, etc., etc. So you check a lot of things, correct? So if you do not know the basics, you may choose certain features or certain columns from the data which are meaningless. So understanding the domain of any given industry will help you to create good solutions. Okay, and so for that only the domain knowledge is desirable. Okay, now you don't have to learn the domain prior to joining a particular job, because you'll be given opportunity to learn the domain on the job. Like for example, in the current project in which I am working on, I was given around 6 months to completely grasp how this particular FMCG domain works. Now let's deep dive into this portion of what is machine learning and what is data science, what is AI, etc., etc. So this statistics plus coding, this portion, this is nothing but machine learning. I mean, when you have the knowledge of statistical algorithm, and you know how to write that code in any one of the language, then basically you are doing machine learning. Okay, so essentially machine learning is the application of statistical algorithms on any coding platform. Does that make sense? Machine learning is application of statistics on any coding platform. Okay, and when you use machine learning, or you can say, and data science, using machine learning, business problem. So when you apply uh, the machine learning techniques to a given domain, like like for example, you need to you are working in insurance industry, let's say. So insurance industry consistently faces a issue. The issue is people try to put fraudulent claims. Like for example, they have an insurance policy of uh, let's say car. Okay, insurance policy for a car, and they did reckless driving, they did a drunk driving, and they put their car into some harm, and then they will come and try to claim the insurance. Okay, so for negligent driving, for drunk driving, the insurance claim will not be true. I mean, they will basically reject your claim. Okay, if you were doing, if you did that accident deliberately, uh, with carelessness, and it was your fault essentially to put yourself there, then the insurance companies will basically try to say that okay, this will not be a true claim. Or let's say you try to create a claim which is fraudulent claim. I mean, you try to claim something which is not legit. So insurance companies every day face a situation where they will have thousands and thousands of claims. So a claim was submitted, claim 1, another claim was submitted, claim 2, another claim was submitted, claim 3, etc., etc. So thousands and thousands of claims are submitted if you think about the overall country level um, insurance customers. And then there are there are a team of insurance adjusters who will tag that okay, whether this is a fraud or not, or this is a good claim. So claim 1, it's a fraud, yes. Claim 2, it's a fraud, No. Claim 3 is a fraud? No. So on and so forth. They will tag this by manually going through all the features of the claim, like what is the amount, how many months the claimant was enrolled, then what was the last claim made, etc., etc. There are so many features, or there are so many inputs that they check before deciding whether it is a fraud or not. Okay. Now this is a painful process. I mean, it involves a lot of human effort. So can machine learning help this process? So this is where machine learning comes into picture. What machine learning says, okay, give me all this historical data which you have tagged already. Okay, for all the claims, let's say there were 10,000 claims so far in the last 2 years which you have tagged, and you have said that this particular claim one is a fraud or not, second one is a fraud or not, third one is a fraud or not. So you have tagged this. So the machine learning algorithm will learn this. Which machine learning algorithm? So algorithm like decision tree, so this will be given to decision tree or logistic regression algorithm. Okay, it will learn it. We will understand going further how it will learn it. And then if you give any new input claim to it, let's say a new claim comes, if you input it, it can predict for you whether it is a fraud claim or whether it is a non fraudulent claim. Okay, it is just like a human, like a new trainee at the insurance company will go through all the previous cases, right, to understand when to say yes and when to say no. That is what training is. Similarly, you train your machine learning algorithm by giving out a lot of examples, and the algorithm will learn this input and output data. And essentially, for any new input which you will provide, it will now try to predict uh, the case. So, if you have a predictive model which can give you the prediction and an early heads up that okay, it looks like fraud, so then you can employ a human to look at, you know, further and make a final decision. And you have screened a lot of cases which are no, because mostly it will be no. Okay, sometimes only the model will say, hey, this looks like fraud. So in those cases you will put some humans, and then they will do further investigation, and a final yes or no can be decided. So this reduces the workload of the team, because you get an indication from the model. Earlier every claim was a suspicious claim, and every time you have to go through each and every bit, but this model uh, can help you reduce that process. In this situation, what algorithm to use? Classification algorithm. Another situation would be where you have to predict the numbers, so there you will try to use regression algorithms. Then sometimes you will have uh, your time series, like only one column is present, like the sales numbers, then you will try to use time series, univariate models, etc., etc. So we will see these scenarios and we'll classify them properly.